Hey guys, here's the review for Spiral 20. We're going to start off with some matrix operations. The big idea here is that we have to figure out if things can work or if they're undefined. So first off, we got two things that are being added together and then multiplied on the outside. First thing that I notice here is that the dimensions here are not the same. This is a 2 by 3 and this is a 4 by 1, and because those are different dimensions, we cannot add those together. So this would be undefined. For number 2, these guys are the same dimensions. They're both 2 by 2. And what I'm going to do is to add the pieces in the middle first and then multiply by 5 on the outside. So it's going to be 5 times the matrix. Negative 2 plus negative 1 is negative 3. Negative 1 plus negative 4 is negative 5. Negative 5 plus 3 is going to be negative 2. And negative 3 plus 2 is going to be negative 1. 5 times these guys is going to give me the matrix negative 15, negative 25, negative 10, and negative 5. At that point, you're done. Moving on to number 3. We've got 5 times a matrix minus another matrix. So what I might do first is to distribute that 5 in. And when we do that, we get negative 25, minus 5, and negative 6. Negative 25 minus 5 is negative 30. Negative 25 minus negative 6 is negative 19. For number 4, we've got some matrices that involve some variables. This is 1 by 2, and this is also 1 by 2. So we're going to start off with the stuff inside the parentheses and then deal with the thing on the outside. So element number 1 is going to be negative 3 plus 3b minus negative 5b, or negative 3 plus 8b. And then element number 2 is going to be 4 minus 4 is 0, leaving me with a final matrix. That's a 1 by 2. First piece, negative 12 plus 32b, and second piece, 0. Moving on, we're going to look at matrix multiplication and some equations. We know we've got to multiply matrices row by column. So I'm going to start looking at row 1 by column 1. And when I try to do this, I notice that these things have 2 elements each. Therefore, I can multiply them. So 1 times 4 is 4, and 0 times negative 4 is 0, giving me a first piece of 4. I'm going to do row 1, column 2. 1 times 2 is 2. 0 times 1 is 0. I get 2. Okay, I'm going to move on to row 2, column 1. Negative 1 times 4 is negative 4. 4 times negative 4 is negative 16. When I add those together, I get negative 20. Row 2, column 2. Negative 1 times 2 is going to be negative 2. 4 times 1 is 4. When I add those together, I get 2. Then we've got row 3, column 1. Negative 2 times 4 is negative 8. 3 times negative 4 is negative 12. Added together, I get negative 20. And then finally, row 3, column 2. Negative 2 times negative 2 is negative 4. Plus 3 times 1 is just 3. Negative 4 plus 3 is going to be negative 1. For number 6, I'm going to try to go row by column. I see I've got 2 elements in my row, 3 elements in my column. I cannot multiply these together. This is undefined. For number 7, I'm going to go row by column. That works here. So row 1, column 1, 3y times 0 is 0. Row 1, column 2, 3y times negative 4 is negative 12y. Row 2, column 1, 3 times 0 is 0. Row 2, column 2, 3 times negative 4 is negative 12. My final matrix is a 2 by 2. The first column is zeros. Number 8, row by column. So we're going to have 2, I'm going to do this one out just so I can keep track of stuff. 2 times negative 3 is negative 6. Negative 6 times 4 is negative 24. And 3 times 0 is 0. And then row 2, column 1, negative 4 times negative 3 is 12. 5 times 4 is 20. And negative 5 times 0 is 0. That's going to give me a matrix that is a 2 by 1. That's negative 30 and 32. Number 9, we're going to solve this matrix equation. My goal here is to get x by itself. And to do that, I'm going to add this matrix to both sides. And I get 2x is equal to negative 10 plus 0 is negative 10. 1 plus negative 9 is negative 8. Negative 9 plus negative 7 is negative 16. I'm going to multiply both sides by half. And I get that x is equal to negative 5 minus 4 and minus 8. For number 10, same process, but I'm going to subtract and then divide by 3. When I subtract this matrix from both sides, so it's 3, negative 5, we get 3x is equal to negative 24 minus 3 is negative 27, and negative 23 minus negative 5 is going to be negative 18. That means that x is equal to negative 9 and negative 6. Moving on to the world of determinants and inverses. First up, we got some determinants. So if we're looking at determinant, we're doing the forward diagonal minus the backward diagonal. 4 times 4 is going to be 16, minus negative 3 times 2 is 6. So we're looking at 16 minus negative 6 is 22. That's the determinant for number 11. For number 12, we're doing another determinant. So negative 3 times 2 is going to be negative 6, minus negative 3 times 1 is negative 3. Negative 3 is our answer. For 13, we're going to find the actual inverse here. So we're going to use the determinant, but this is going full inverse. We know that the inverse is going to be 1 over the determinant of the matrix. And then we're going to flip our forward diagonal and make the backward diagonal the opposite sign of what it is. So in looking at this, my determinant is going to be 15 minus 15, which is 0. This is going to be kind of interesting. So we get 1 over 0, and theoretically we should be multiplying by this. But because this would cause us to divide by 0, this one doesn't actually have an inverse. And that's because we're dividing by 0 here. So number 14, I'm going to do the same thing. I'm going to find my determinant first. We've got 8 minus, in this case, is 0. Okay, and I'm going to build my inverse. 1 over the determinant, 1 over 8. I'm going to flip my forward diagonal 1 and 8. Change the sign of the backwards one. And we're done. For number 15, now we've got to use an inverse to solve this equation. So we're going to multiply both sides of our equation on the left by the inverse of this matrix. Just to kind of see what's going on here, we've got a determinant of 5 minus 8 is negative 3. it'll be 1 over negative 3 out front. 5, 1 get flipped. 2, 4. I'm going to just cover my bases and rewrite this. We got b, and then on the other side we got 1 over negative 3, and then we've got this inverse guy, 5, 4, 2, 1, multiplied by negative 20 and 31. This is the part that I would be okay if you wanted to use technology on, but know that on the left side, all of this stuff cancels out to b, because a matrix multiplied by its inverse is equal to the identity. And on the right side, we got 1 over negative 3. We got 5 times negative 20, which is negative 100, plus 4 times 31, which is 124, which is going to be 24. On the bottom, we got 2 times negative 20, which is negative 40, and 1 times 31 is 31, which gives me negative 9. When I finish this off by multiplying that in, we get negative 8 on top and positive 3 on the bottom. For number 16, we're doing the same thing. We just kind of switched sides as far as what's going on here. And in looking at this, we got a determinant of negative 30 minus negative 30, which is 0. And just like above, if we have a determinant of 0, that gives us no solution. And the reason for that is that we can't actually get an inverse for this. In looking at this as a system of equations, because this would all be the same in both things, this would actually end up being an infinite solution type thing. But because the matrix is not invertible, we cannot solve this. And finally, we've got some row operation stuff. You've got to be able to write these as an augmented matrix and do some row ops in order to make sense of what's going on here. So I'm going to set this up as an augmented matrix first. We've got 2, negative 2, negative 3, 0. We've got negative 2, negative 2, 1, and negative 8. We've got 0, negative 3, 3, and negative 15. And in order to do some row ops for this, I know that I'm trying to make this look like the identity. So one of the things that I need to do is I need to make this top left equal to 1. I also need to make the middle left equal to 0. Because I've got these to be the same term already, what I'm going to do is to replace row 2 with row 1 plus row 2. And in doing that, that's going to give me 2, negative 2, negative 3, 0 on top. But then 2 plus negative 2 is 0. Negative 2 plus negative 2 is negative 4. Negative 3 plus 1 is negative 2. And 0 plus negative 8 is negative 8. I like doing that first here because that saves me from getting some fractions. And I'm just going to rewrite row 3. That also makes this a little bit easier to deal with because now I'm already done with getting those zeros. Getting those zeros is actually much more important than trying to get the ones in position. Those can come later. In looking at this guy, I also notice that both row 2 and row 3 are all multiples of the same number. Just for the sake of cleaning this up, it might be nice if I were to divide these by 2 and 3 respectively. I don't know if that's actually going to be helpful, but that makes this easier for us to work with. So we got negative 2, we got 1, and we got negative 4. And then in the bottom we got negative 1, we got 1, and we got negative 5. Okay. I know that I need to make the middle a 1, or the bottom right a 1. Since I already have the bottom right's equal to 1, I'm going to deal with that one first. And I know that to get rid of this, if I do negative row 3 plus row 2 and use that to replace row 2, that will turn this guy into 0. And if I do 3 times row 3 plus row 1 to replace row 1, that'll get rid of that 0. So in doing that, we got 0 plus 2 is 2. We got 3 times negative 1 is negative 3, plus negative 2 is negative 5. And we get 1 times 3 plus negative 3 is 0. Then we got 3 times negative 5 is negative 15, plus 0 is negative 15. For the second one, we've got 0 plus 0 is 0. We've got negative 1 plus negative 2 is negative 3. We've got negative 1 plus, actually this should be negative 1 here. Negative 1 plus 1 is 0. And negative 5 minus 4 is going to be 1. The last row remains the same, 0, negative 1, 1, and negative 5. That leaves us with just the middle column for us to deal with. So the first thing I've got to do is to make this into a positive 1. And in looking at that, I'm going to multiply that row by negative 1. So row 2 times negative 1 is going to become row 2. That's going to make that row 0, 1, 0, negative 1. The other thing I might take a look at is that if I do negative 1 times row 2 plus row 3, that's going to get rid of that negative 1 there. And that's going to replace row 3. So we end up having 0, 0, 1, and negative 1 plus negative 5 is negative 6. And then if I want to get rid of the negative 5 up here, if we do negative 1 row 2, actually that has to be negative 5 row 2, plus row 1. And replace that with row 1. We end up with 2, 0, 0, and then negative 5 times 1 is going to be negative 5, plus negative 15 is negative 20. And then finally, I got to divide row 1 by 2 and replace row 1 with that. That gives me 1, 0, 0, negative 10, 0, 1, 0, negative 1, 0, 0, 1, negative 6, which means that x equals negative 10, y equals negative 1, and z equals negative 6. For the next one, we've got 3x plus 3y minus z equals negative 2. That's going to make a row that's 3, 3, negative 1, negative 2. 2x plus y equals 1, so that's going to be 2, 1, 0, 1. And then we're looking at negative 3x minus 2y plus 2z, so negative 3, negative 2, 2, negative 2. And we're looking at doing the same type of thing. A couple things that I notice. The first is that I've already got a 1 in the middle, which I need, and I might use that to get rid of the things above and below that. So that would be negative 3 row 2 plus row 1 to replace row 1, and positive 2 row 2 plus row 3 to replace row 3. So in looking at this, so negative 3 row 2 Be negative 6 plus 3 is negative 3. Negative 3 plus 3 is 0. And 0 plus negative 1 is negative 1. Negative 3 plus negative 2 is negative 5. Keeping row 2 the same, 2, 1, 0, 1. And row 3, we're looking at negative 2, or positive 2 times row 2. So 4 plus negative 3 is going to be 1. 2 plus negative 2 is 0. And 0 plus 2 is 2. 1 plus negative 2 is 0. Okay. That gets us through the middle column. My next set of things to do is going to be a little bit more challenging because I've got to figure out, if I'm lazy, and I am lazy, how to avoid doing this with fractions. And one way for me to do that would be to use this 1 to get rid of this 2, and that would give us zeros in 2 out of the 3 rows here. We're also going to have to do some switching of things in order to make this look the way that we like to look, but for now, let's start with that. So we're looking at row 1 times 2 plus row 3, and we're going to use that to replace row 3. So we end up with, for row 3, negative 3 times 2 is negative 6, plus 1 is going to be negative 5. We get 0. Then we get 0. And 2 times negative 5 plus 0 is going to be negative 10. I'm going to keep row 2 the same for now. 2, 1, 0, and 1. And the other thing that I might do here is turn this negative 1 into a positive 1 just to kind of see how that works. So we end up with row 1 times negative 1 to replace row 1. And that's going to give us 3, 0, 1, and 5. Okay, I've now got 2 columns all set. I've got to deal with my third column. Easiest one for me to work with, in fact the one I have to work with, is the bottom row, because I've got zeros in my other 2 places. I'm going to start by dividing by 5. So row 3 divided by 5. Let's make that divide by negative 5. And we get 3, 0, 1, 5, 2, 1, 0, 1, and 1, 0, 0, 2. Okay? We're going to use that to get rid of the rest of that column. To get rid of row 2, we're going to do negative 2 times row 3, plus row 2 is going to become row 2. So that's going to be row 3 staying the same, 1, 0, 0, 2. That gives us 0, 1, 0. And then negative 2 times 2 is negative 4, plus 1 is negative 3. And to get rid of the 3 in row 1, what we're going to do is multiply negative 3 times row 3 plus row 1, and that becomes row 1. That gives me 0, 0, 1, and negative 3 times 2 is negative 6, plus 5 is negative 1. This works even though we have a backwards diagonal going on here. This just means that z is negative 1, that y is negative 3, and that x is 2. The lesson here might be that sometimes it's a better idea to go out of order in terms of lining things up and getting things to be 0 when you can. For number 19, we've got another system. I'm going to write this in augmented form, so 1, negative 3, negative 3, negative 3, 0, negative 2, negative 1, 0, and then -1, -1, -2, and -3. Okay, and looking at this, I've already got a 1 in the top left, and I've got a 0 below it, so this is a great column to start working with. The first thing I'm going to do is say that row 1 plus row 3 is going to become row 3. And I'm going to rewrite everything else. So 1, -3, -3, -3, 0, -2, -1, 0. Then we've got 0, -4, -5, -6. Okay. The next thing that I noticed, the easiest thing for me to work with, is I've got a 1 in the last spot of the second row. I'm going to do a quick change and make both of these positive instead of redoing the entire matrix. I then might use that to get rid of the stuff in row 1 and in row 3. So that would be 3 row 2 plus row 1 replaces row 1. So that's 1, and then 3 row 2 is going to be 6 minus 3 is 3, and then that's going to be 0 and -3. I might also say that 5 row 2 plus row 3 is going to become row 3. I'm going to leave row 2 alone. 2, 1, 0. And for row 3, we're doing 5 row 2, so that's going to be 10 minus 4 is 6. And 5 minus 5 is 0. 0 minus 6 is -6. Okay. I might also do another quick change. I've got 6 and -6 in the last row. I might divide this both by 6 and get 1 and -1. So that way when I go to eliminate these two, I can say that we're doing -2 row 3 plus row 2 to make row 2, and -3 row 3 plus row 1 to remake row 1. When we do that, we get 1, 0, 0. This is going to be 0 and 0 and 1. And then that's not going to change. 0 and 1 and 0. So -3 times row 3 is going to be +3. -3 is going to be 0. -2 row 3 is going to be -2. +2 rather, plus row 2 is 2. And we are at this point done. And again, as long as you have 1 in each row and each column and everything else is zeros, you're okay. If you'd like to reorganize this, you could swap rows 2 and 3, but you don't have to know that x equals 0, that z equals 2, and that y equals -1. And finally, problem 20. We're going to start off with our augmented matrix, which is 1, 0, 3, -6, -3, -2, -1, -6, 3, -2, 2, and 3. Again, I've already got that 1 going on in the top left corner, so we might say 3 row 1 plus row 2 to replace row 2, and 3 row 1, -3 row 1 plus row 3 to replace row 3. Top row is going to stay the same, so 1, 0, 3, -6. 3 plus -3 is going to be 0. 0 plus -2 is -2. 9 plus -1 is going to be 8. And -18 plus -6 is going to be -24. And then -3, doing the same thing. We get 0, -2. -3 times 3 is going to be negative 9, plus 2 is going to be negative 7. And positive 18 plus 3 is going to be 21. All right, so now we've got the first column taken care of. I noticed that my second row, everything's divisible by 2. Let's do a quick divide by negative 2 to turn that into 1, negative 4, and positive 12, just so that we don't have to do that as a separate thing and rewrite everything. Okay, to get rid of my next thing, which is that bottom negative 2, I'm going to take my newly minted row 2, multiply it by 2, and add it to row 3. So that's going to change just row 3. And then we've got 2 plus negative 2 is 0. We've got negative 8 plus negative 7 is negative 15. And we've got 2 times 12 is 24, plus 21 is going to be 45. Okay, similarly to what we just did, if I divide everything in this row, at the bottom row now, by negative 15, that gives us positive 1 and negative 3. That lets us quickly jump into the last piece of this. So we have to do negative 3 row 3 plus row 1 to replace row 1. We get 1, 0, 0. Negative 3 times negative 3 is going to be 9 minus 6 is 3. And then if I do 4 row 3 plus row 2, that gives us row 2. We end up with 0, 1, 0, and 4 times negative 3 is going to be negative 12, plus 12 is 0. And then finally 0, 0, 1, negative 3. This one did give us that reduced row echelon form, RREF, and we get x equals 3, y equals 0, and z equals negative 3.